All right, so here's a little hint to help out with estimating the sort of an upper bound, let's say, on the typical maximum of a sample from Poisson degree distributions, or Poisson distribution in general. So, and here's the more general story, right? So we have some probability distribution, discrete or continuous. Of course, we're going to think about discrete ones, but the sketch here is continuous. So, right, we're interested in figuring out what this, given an n, what min k max would be. So this is we expect one of our n samples, given we make n samples, capital N samples, to fall in this range, right? So if this area under the curve here, right, so the total area is 1, it's a probability distribution, 1 over n, means we expect 1 out of n to be in here. All right, so that's written down mathematically here, right? So we probably have k is greater than or equal to this min k max, so k max is somewhere in here. It's approximately 1 over n. So Poisson, we'll stick everything in. It's exactly this business here. So lambda k e to the minus lambda over k factorial. Want this to be about 1 over n. So there are two steps to notice here. You can do this in various ways, but I think we're going to make some very rough approximations. The first is just really to argue that the first term in this sum dominates, right? So we can pull out, e to the minus lambda. So I'm just going to work on this side. So we'll pull out e to the minus lambda, that's true of all these things, and then we can pull out lambda to the k and k factorial. The first term is just 1, then there's a plus lambda over k plus 1, plus lambda squared over k plus 1, k plus 2, plus dot dot dot, right? So for large enough k, this stuff is pretty small. You can see this is going to go away, all right? That's rough. So that's our first bit. Now we have a bit of a mess on this side, and I should say this is, what I'm going to do is call min k max. We'll make this a little bit easier. Let's call this tilde, all right? Spur of the moment decision there. All right, so I know, crazy. Tilde equals min, be a bit unwieldy otherwise. So we wanted to extract this k tilde, or the min k max, out of this thing. Now that's going to be 1 over n. It's really just this business. We use Stirling's approximation because that's what we always do. And that will give us some more powers of k, right? There'll be k to the k plus a half. There'll be an e to the minus k in there. Lambda is e to the minus k. It's all k tilde. Right? Lambda to the k tilde is e to the k tilde ln of lambda. Use that. K tilde factorial is approximately root 2 pi k tilde to the k tilde plus half e to the minus k tilde. So use these guys, and what you want to end up showing is something messing around. You'll be able to, oh, someone fell off. You want to get rid of some k. You'll be able to drop some things off. We want to get to this result that k tilde, which is min k max, is smaller than, right, log n of n. So it's growing very slowly. That is the result you want to get to, and I think you can do it through some sneaky methods. Okay.